All right, so we were comparing the terrestrial planets, the four terrestrial planets. We included this slide includes the moon to, um, you know, it's not a terrestrial planet, but uh, and actually, I should put this out there a little bit. So the moon. Remember I mentioned before that the moon and the Earth are very similar in size, right? That is, the moon is very large to uh, compared to its host planet. Our moon is large compared to its host planet, not the largest moon at all in the solar system, but so some people have gone as far, and I don't do this, but some people have gone as far as to say, that it's the Earth Moon system. Um, but anyhow, the Earth is quite different than the moon. Um, I think it's safe to just call the moon its own independent object. All right, let's move on here. Okay, so the consequence of planetary mass. A large mass of rock and iron has a large radius and a strong surface gravity. Higher surface gravity helps retain the atmosphere. Of course, remember Mars has a very weak atmosphere. Um, Mercury has no atmosphere, and of course, our moon has no atmosphere because Mercury and our moon are too small to hold on to an atmosphere. It's not like they don't get gas occasionally. Like there's going to be some gaseous object that hits Mercury and hits the moon, like a comet or something like that, and so the gas will stick around for a while, but it doesn't stay. There's no permanent moon because those gas molecules will be hit by sunlight, and the sunlight that's thermal energy. When the thermal energy basically turns into heat, which is motion, and that motion will cause the molecules to escape into space. All right, so large radius reduces the heat loss. Remember, we learned that the heat loss was basically 3 over the radius of a planet. And so the bigger the bigger the planet, the more it was able to retain the heat. It keeps the internal temperature high, and it keeps tectonic activity going on. So remember, we think that Mars once had a lot of tectonic activity. It might still have some, but it doesn't. It's certainly not as strong as the tectonic activity that's on the Earth and presumably on Venus. Although it's hard to tell. There is evidence that Venus had recent tectonic, not tectonic activity, but it recently resurfaced itself. Um, we don't think Venus actually has plates the way the Earth does. Um, all right, so an active interior allows magnetic dynamo, which in other words, there's a liquid, at least the outer core is liquid, and so that spins at a different rate than the surface. That's what's called the dynamo effect, and that prevents solar wind from slowly stripping away the atmosphere, which is basically what happened with Mars. Mars's atmosphere is um, very thin compared to what it used to be, what we think it once was. Active volcanic activity resurfaces the planet. And that's we think that's what's going on with Venus. That there in the past, in the recent past, we think that there was a little bit of volcanic activity on Mars as well. That's how Olympus Mons got there and Valles Marineris. Um, and of course, that adds gases to the atmosphere. In particular, it tends to add a lot of carbon dioxide. So Mars, Venus, and Earth are all probably started with carbon dioxide. Atmospheres trace nitrogen and water. And then what happens is the sunlight modifies this, and then, on Earth, of course, um, life converts water water molecules and carbon dioxide molecules through the process of photosynthesis into oxygen, O2 molecules, which of course animals need to breathe. But of course the plants came along first. So anyhow, tectonic activity, and of course with Earth there was life. We think maybe there was life once on Mars. Venus, it seems pretty unlikely that there was ever life there. There was some evidence that maybe there was something in some kind of microbial life in the atmosphere of Venus that was very popular about 5 years ago. That has the opinion of scientists has changed regarding that. The evidence that we determined could be explained in other ways than life. Venus is a very harsh place, very inhospitable to living things. First of all, the surface temperature of it is it's well above what's called the sterilization temperature. Sterilization temperature is the point where nothing can live. And so there's not ever going to be anything on the surface of Venus. All right, so Mars, as I said, we think someday we're searching for this. Someday we hope to find, evidence of ancient microbial life. We don't think it evolved anything past microbial, the microbial stages. But if we found evidence that there was once life on Mars, that would be the first place other than the Earth that has life. That's not the only place in the solar system, by the way. We're going to investigate some other places in the solar system. The low mass of Mercury and our moon make them unable to hold atmospheres. And all right, so let's look at the evolutions. The evolution of the different planets. All right, so the planet accretes from smaller bodies. These are generally called planetesimals. Solid forms from the impact. So when there was lots of impacts in the early parts of the solar system, sometimes those impacts even broke the material apart even more. But there were some times when the impacts caused there to be a larger object, like two things collided and they kind of stuck together, and that's eventually what forms the planets. All right. Major cratering and this time is called the late heavy bombardment in the age of the solar system. Volcanic activity releases gases and fills basins with lava. Right. That's of course what happened on the moon with the Maria. Internal convection in the mantle produces volcanoes and a crustal deformation. So notice that's what was going on with the Earth and with Venus. The mantle solidifies. So this is beyond where the Earth is right now. Right, the mantle solidifies. The core is still molten, but tectonic activity has ended on the surface, and the atmosphere begins to dissipate into space. Notice that's right where Mars is at. Over time, its atmosphere will almost be non-existent. As it is, there's no atmosphere on Mercury. There's no atmosphere on the moon. When the planet, when the world, we're talking including the moon. We don't. It's not a planet, of course, but we're including the moon here to compare in this comparison. When the interior cools off, all tectonic activity stops, right? Or all significant tectonic activity. There are little tiny moonquakes, but there's not a lot going on the moon. As far as Mercury goes, we don't exactly know if there's, there's no, we don't have any evidence, because we haven't landed anything on Mercury um, to determine whether there's, quakes on Mercury. But we think it's pretty, since it's very similar to the moon, it's approaching this stage very quickly. Well, not very quickly. This is going to take billions of years. All right, so there's that. Consequence of, okay, so the closer a planet is from the sun, the more sunlight it receives, and the warmer it's expected to be. I don't know why this is here, but I mean, it's not like we can do this, but if you were to swap the places of, put Mercury where Mars is and Mars where Mercury is, they may both be more Earth-like. There's no way to do that. Okay, don't. That's a science fiction fantasy. All right. Anyhow, the amount of warming depends on the amount and makeup of the atmosphere. Of course, with Venus and Mars, there's a lot of carbon dioxide. With Venus, the carbon dioxide traps the heat. Gravitational effects are stronger closer to the sun, like tidal breaking experienced by Mercury and Venus that alters the length of their solar day. It takes those two a long time to rotate around once on their axes. Hotter atmospheres makes it difficult for water to condense and, of course, become rain, which is, the water cycle is absolutely essential for life on the surface of Earth. Let's see. For example, Venus's water is lifted high up in the atmosphere, allowed to photodissociate. That's so the molecules are the molecule of two hydrogen and oxygen separate because the sunlight is so intense, and so the hydrogen floats off into space and leaves behind some oxygen in the upper atmosphere. All right. Let's see. Great differences in water in the upper atmosphere. Water contents in the upper atmosphere of Earth and Venus led to drastically differences in atmosphere at the lower levels. So, Venus has lost most of its water, whereas Earth it's protected, and so it keeps its water. The surface water shapes Earth's landscape and produces erosion, sedimentary rock. Water in surface rock alters the chemistry, perhaps also alters the tectonics from processes. The Earth's continents are made of granite, which form deep underground in the presence of water. Water alters the composition of the atmosphere's carbon dioxide is removed from the atmosphere by dissolved water. Water also made the rain slightly acidic, and that acidity reacts with rocks and creates carbonates. Without carbonates, our atmosphere would be very similar to Venus. All right. Biological process has removed carbon dioxide from our atmosphere. Dissolved carbon dioxide in the ocean is used by sea creatures to make shells, which are called, the shells are calcium carbonate. When sea life dies, the shells hit the bottom and that becomes more sedimentary rock. The sediments eventually change to rock. And, the CO2 is, sometimes people call it, it's sequestered. So it's still there. It's just, anyhow. All right. So that's, that is what life does. There's our worlds, the different terrestrial worlds. All right. So we've already talked about these, the different surfaces. All right. So this is just the process of forming the planets. All right, so that is it for chapter 8. I'm gonna do some videos showing you how to do the the practice problems, the sample problems, which that's going to be like testing